Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it free today. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code C101 in the billing section for a $10 credit. And by Braintree. If you're working on a mobile app and searching for the right payments API, check out the Braintree V.0 SDK. With one simple integration, you get every way to pay. To learn more and to try out the sandbox, go to BraintreePayments.com/coding. Today on Coding 101, we're continuing down the iOS road. Click. Welcome to Coding 101. It's the show where we let you into the wonderful world of the Code Monkey and the Code Warrior. I am Father Robert Balliser, and joining me today, as always, is my, I'm just going to say co-host. We're going to be really boring today and say co-host Lou Maresca. Lou, so good to see you again, my friend.
Hey, Padre, good to see you too.
Now, it's been an interesting couple of weeks. We had a couple of pre-records because we wanted to stock up on some iOS goodness. And then you had to worry about a different kind of code, like human biology code, the last couple of weeks. You feeling better?
We got a nasty stomach cold, and the whole family got it. We were, inside getting fever, had fevers and all that stuff. So we're all over it. We're all good to go, and we're ready for some iOS programming. Yes,
we like programming. And just remember, having kids is like having little incubators of disease and viruses in your house. That's just how it works. But you know what? Let's not talk about disease and viruses because we've got some really, really good news. This actually has me excited. For any of you makers out there, you geeks who like to program with the Arduino or with microprocessors, well, we're going to make it a little bit easier, aren't we, Lou?
Absolutely. So Visual Micro has built a private add-in that allows for Visual Studio that actually allows you to view your sketches, compile your sketches for all different types of Arduino boards, and it's actually transferable. So it can transfer between the Studio and Visual Studio back and forth, and you shouldn't have any differences between your sketches or your code itself.
Right. I've played with a couple of frameworks that work really, really well for the Arduino branded line of microprocessors, but this one will work with, what is it, with Adafruit, with Arduino, with Teensy, SparkFun, Wang Energia, all the Atmel, like Bear microprocessors, along with Intel, Digistump. So it's really, if you like doing any sort of maker stuff with microprocessors, this is now the de facto standard for doing your development.
Absolutely. I think the kind of the unique thing about it too is if you still want to use Arduino IDE, you can build your stuff there. You can move it. You can go from Atmel Studio. You can build it over there. You can go in between the two, and also lets you kind of support some of the newer boards that are out there. Like you said, there's a long list of them that you have, but they are adding them all the time. And plus, there's some older versions of what I've seen. That's some of the comments online saying, oh, it's not necessarily working with my old version, like 1.1. Of like our Adafruit, but like 1.6 is working. So there are some versioning differences, but other than that, it seems to be working pretty well across boards.
I had a discussion with a few of my maker friends, and they were actually saying they were excited for this because of security. And let me explain what they mean by that. They were saying, look, one of the issues we've had a lot with people who are just making things is if you're just a tinkerer and you're throwing together some hardware and software, you're so happy when it works, you don't ever consider that it's actually a project that needs to be devved. It needs to be revved. You need to actually test it, especially if you're going to be connecting it to a network. They're hoping that the creation of this IDE will give people a better indication of, look, I'm happy that you got your lights to flash and your motors to turn the way that you want them to, but if you're now going to make this an Internet of Thing, you need to consider it as a complete program, including security. Do you think, does that valid, or are people just going to make bad mistakes no matter what they're developing in?
I think exactly that. I think people will make mistakes no matter what, but these types of environments make it easier for you to kind of have the end-to-end scenarios, like making sure you're testing, making sure you think about security, And being in Visual Studio, with the ability to kind of do the end-to-end, whether it's unit tests or whatnot, it gives you that capability, that environment to kind of make sure that you're doing the right thing. But again, like you said, it's all dependent on the user and it all dependent on whether they take that advantage or not.
I will be making bad code. I'll just tell you that off the bat. I am interested to see how you move from platform to platform, though, because that actually has me excited, especially since I'm starting to do my own custom flight controllers for my quadcopter hobby. I'd like to see if I could take some code that I know works and put it on my own custom platform. Well, we'll see. But that's not the only thing we want to cover today, Lou. Tell me a little bit about modern code editors.
Absolutely. So, I mean, a lot of people out there, they either like to use an IDE or some people like to use editors. And there are editors that have been around for a really long time, like Emacs and so on. But there are some of the common or some of the newer editors out there that are actually kind of coming out of the woodwork and really making it useful for people. And I wanted to talk about what makes a good code editor. What do you think makes a good code editor, and what should you be looking for, right? And so one of the big ones is obviously nowadays is that it's cross-platform. Making sure that the editor, you're coding it maybe on your OS X machine, but you need to run over and use your Windows machine. Making sure that it kind of goes between those two is kind of important, right? The other couple things is syntax highlighting and coloring, meaning making sure that depending on the programming language that you're using, making sure it's highlighting it correctly, telling you what an object is or class is, maybe a struct, or maybe even an object in JavaScript, that kind of thing, making sure it's syntax highlighting for you. Then there's some other things that make it even better is IntelliSense and linting. And those are important because, IntelliSense means that it gives you the ability to program and give you examples and be able to tell you what you're typing is actually available to you in the language. And so that's also important. And linting is really the process of, looking through your program before you compile it and link it and all that stuff, and actually tell you if there's anything it's found that's wrong. And so that's actually important for a lot of different things out there. For instance, JavaScript, linting is pretty important because it's not a compiled language, that kind of thing. So these are also very important when it comes to IDEs. And then there's some other syntactical sugar, we call it syntactical sugar or sugar on top when it comes to other editors. But there's, the ability to refactor your code. So like, right click and say, I want to rename this object across all different pieces of my code, whether I'm using it over here or I'm using it over here, refactor it, rename it for me. And then, of course, what they call find all references, meaning giving you the ability to say, hey, I'm using this object over here, but I also want to know who else is using it. And so that gives you the ability to kind of find that. So these are all things that you should be looking for when it comes to a code editor.
Right. And, it's funny because people become attached to their code editors, even when they realize that there's a lot of flaws, or if there's a code editor that does exactly what they want a little bit better. It's kind of like a spiritual thing. It's a religious thing. I know people who still swear by Emacs, and they don't care what else comes out. They will use Emacs. Is that just a coding thing? I mean, I kind of do it too. So
it's I'm gonna be honest with you. It's a coding thing. It's a ritual thing. It's an ego thing. There's a lot of things kind of going on.
Real programmers use Emacs, Lou. If you need something more than Emacs, then you're using a crutch.
That's right. I honestly, I like to use the tools that just, they give you the advantage, let you do things faster. You obviously, if you're a pretty seasoned coder, then you know what you're doing. So do you need to use Notepad, Emacs? Probably not. These other tools make it easier for you to know what's going on and how to do it. And so, why not use them, right? They're not a crutch. They're not going to make you worse. So. Right.
But on the other hand, to be fair, I've also seen the other trend, which is these things are coming out so often and everyone promises to be so much better that some experienced programmers will say, I'm tired of relearning. Look, this works. Maybe it's not perfect, but actually we've got Dallas in the chat room who says absolutely correctly, for a lot of people, this is just muscle memory. If their hands just automatically do the keystrokes for whatever editor they're using, right, that's probably a good place to stay. Lou, let's give them one more hit of good news. You've got something coming from your home farm. Tell me what's going on with Visual Studio.
So Visual Studio Code, you guys have heard, is actually a cross-platform editor that gives you kind of all the above type of functionality when it comes to different languages. It gives you syntax coloring for, you name it, Batch script, C++, Clojure, Python, Ruby, SQL, Visual Basic, C#, that kind of thing. It also gives you IntelliSense and linting for things like HTML, JavaScript, less CSS, that kind of thing. And the nice thing is it works not only on Mac and OS X, but it works on Windows, it works on Linux. It gives you the ability to kind of have the same ID across those platforms. Plus, it's ingrained in its DNA. It's, it does things like TypeScript, Node. It does package management. It does syntax highlighting, like I said. It does a whole bunch of things. Refactoring of code really makes it really easy for you. And the really cool thing about it is it's actually built on top of an engine called the Electron engine. And if you've ever used the Atom editor, which is an editor that you can use in Windows or OS X, it's kind of like a cross between a web application and a native application. And its framework is called Electron. And so the Visual Studio Code is actually built on top of that. It's kind of cool because when you actually run the application, it's literally like a 1-second install. The app kind of opens, and it's more of like a portable app, and it just immediately opens and starts running. And there's a big difference between that and Visual Studio itself, which could take you 30, 40 minutes to install. So it's kind of a cool editor.
Yeah, well, if you've got an inkling at a little bit of time, where can they download that?
So you can always check it out at code.visualstudio.com, and it'll kind of work you through what's available out there, what it can do, how to install it, how to add the different functionality to, whether it's Node or ASP.NET. And again, it's a really simple, easy install, and you can use it on Mac and OS X and Windows and Linux.
Of course, it's no Emacs or Notepad, but maybe you want to give it a try. Hey, Lou. How would you feel about jumping back onto iOS road? We've got Todd Perkins back, and you feeling some iOS love?
I am. Yeah. I'm ready to go.
But before we get there, let's go ahead and thank the first sponsor of this episode of Coding 101. Now, let me ask you a little something. When you're developing, when you're trying to get your product or service out in the open, what do you have to do? I mean, yes, it's nice to develop on your home system, maybe your home network, but at some point, you got to start exposing it to real traffic, to real people. So at some point, you need to make it available to the real world. Now, in the old way, you would stand up your own servers. Maybe you would rent a high bandwidth pipe. Maybe you rented some colo space and got your own rack. Well, you could still do that. That's definitely a possibility if that's what your application demands. But if you're not into long nights and frustrating paperwork, maybe instead, you might want to try DigitalOcean. DigitalOcean is the place to go if you are a developer, whether you're a beginner or experienced. You need flexible, reliable, and affordable hosting. That's exactly what DigitalOcean provides. They give you Droplets, which are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtualized desktops, and pretty much everything else you can think of with full root access. Now, one of the things that I love about DigitalOcean and their Droplets is the fact that you can scale with not a thought. You start with just a couple of hours of time so that you can test to see if it'll survive in the real world. Maybe you want to throw some beta users at your service to find if they can break it. And then, if everything goes well, you go ahead and scale it up. Open up your own SSD cloud. Go ahead and go across multiple servers, multiple processors, take up more and more space. That's what DigitalOcean gives you, a way to grow from zero to infinity. It's built for developers, and it's used by over 400,000 of them, including Twit. You can deploy and configure your Droplets via a streamlined control panel or a simple API. You get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, FreeBSD, anything. One-click install allows you to quickly deploy apps like Django, Docker, Drupal, LAMP, GitLab, MediaWiki, Node.js, WordPress, Ghost, Magneto, OwnCloud, Ruby on Rails, and more. I'm running out of breath. All servers are built on hex-core machines with dedicated ECC memory and RAID SSD storage. Servers can have up to 20 CPUs, 64 gigabytes of memory, and 640 gigabytes of SSD space. It's highly scalable to meet the demands of a rapidly growing application or business, and their auto backups and snapshots let you easily clone, deploy, and resize Droplets as you go. I can't stress how important that is. If you're just starting up an enterprise, starting up a service, it's easy to throw everything, all the caution to the wind because you just want to grow as quickly as possible. Well, you don't have to sacrifice security and backups in order to make that happen. DigitalOcean will do it automatically. You can even deploy servers in regions all around the world with gigabit speed, 99.99% uptimes, and full DNS management, including the use of dedicated IPs. Now, they've got an active community, which is one of the ways that I judge a service, because you want to know if their customers are happy, and well, DigitalOcean has one of the best. It's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. Are there really any reasons left not to try DigitalOcean? Well, in case there is, let me give you one more reason. DigitalOcean has incredible, affordable, and straightforward pricing, starting at just $5 per month. There's also hourly pricing available, starting at less than a penny per hour. But we're going to make it easy. You can get started today and deploy an SSD cloud server for free. That's right, 0 cents, $0 gratis. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code C101 for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com. And once you sign up, enter the code C101 in the billing section for a $10 credit. And we thank DigitalOcean for their support of Coding 101. Ladies and gentlemen, we welcome back to the show our iOS guru, a member of the Linda staff, a self-taught iOS expert, Mr. Todd Perkins. Todd, thank you very much for coming back on the Coding 101.
Hi.
Now,
thanks for having me.
When you last left us, our audience was loving it, by the way. They've been wanting to do iOS stuff, iOS programming for quite a while. You were starting to give us a taste for what the development environment looks like, what people could do, and how the programming process goes. Today, you want to show us how to build a simple note-taking app.
Yeah, that's right. I've built an app. I have the finished code on my screen. And if you'd like, I can take you through a tour of the code that we'll write, and then we can build the app from scratch.
All right, yeah. So take us step by step, because people have been watching your episodes. They've seen you program, but go ahead and show us what the logic is of the program here.
Okay. And again, we'll build this from scratch in a minute. I just want to show you what's involved in creating this app. And also what it's going to do, so that when we actually write the code, that you have some sort of idea of what we're working towards. So here is the one class that we're going to build is called Note. And this is going to be serve as our data model. It's going to store an array of note objects. And each note is going to have both a note property and a date property. The note property contains the text of the note, which is a string, and the date property is going to contain a unique timestamp. And that's going to be a date timestamp as a string.
Okay.
And the way that our data is stored is simply an array of those objects, and here's all the code that we're going to write. And it looks like a lot, but if you look at the top half of it, it's just simple getters and setters. So there's really not a lot of logic here. It starts on line 45 and then goes down to about line 89. And then we're going to modify some code in this class. And the vast majority of this code is already built into an iOS template. So we're just going to modify the template from using a generic array to using our array in the note class.
Now, these libraries that you're using, are they loaded up in the default setting for the IDE?
Yeah. The only thing that's not default is my note class right here. Okay. So when you create the template that we're going to create, and this is just built into Xcode, it's going to have these three classes up here: app delegate, master view controller, and detail view controller. Okay. So all this code's going to be written. We're just going to modify it to use our array of notes instead of the generic array that the template uses. And then in this class here, detail view controller, we're going to write one method right here, and this is basically going to save the data. So let's, can I show, I'm going to have to go to another application and show
absolutely
what it looks like in the finished app, and then we could start writing it. Let's see.
So you're switching from the IDE to what?
I am switching to the iOS simulator.
Oh, okay.
Now, you mentioned earlier that you're going to need to pay to really get into iOS development. You don't have to pay to do this much. So you can use the simulator, you can develop an app. You're just going to have to pay to get it on a device.
Exactly. Yeah, that's what I was trying to tell people, which is if you just want to try out your programming skills, that's completely free. All the tools that Todd has been showing you in his module, you can download them and install them for free. if you want to push it onto a phone, unless you really want to jailbreak it and do it that way, you do have to pay the fee to become a developer.
Right.
Yeah.
Okay, so here is the app. I'm trying to show it. I don't know if that's working or not. Do I have to hit the show button? Oh, I do.
There you go. There you go.
Okay, beautiful. Okay, so this is our finished application, and it's really simple. Okay, I tried to kind of mimic the Notes app that's built into iOS, so it really doesn't do a whole lot. So we have this list right here, which is in iOS is called UI Table View, and you click the plus button, and it takes you into a detail view, and the keyboard pops up, and you can type out a note. So let's say I just wrote hi in there. And then the note text is shown in a list right here. And so I can click to add additional notes. And there it is. And of course, I can edit the notes.
And it's storing this using that the date information, date and time information that you pulled.
Yeah. Yeah. Each note has like the timestamp attached to it. So if we want to, we could. We're not going to do this in this tutorial, but if we wanted to, we could sort them based on that date.
Okay.
And then it has the note properties, and then we can click the edit button. This is built into the template, so I actually don't even have to write this code to do it, but we can edit these and hit done, and it's all saved to persistent storage. So if I close out the app, and I'm not actually closing it out right now, I'm just going to the home screen, but just imagine that I closed it for real. If I open, I guess I could just, I don't know if I can do that.
Persistent storage is just what, laying it on the device somewhere that's like part of your sandbox, your app?
Yeah. It's saving it, so if I close the application, it's saved in the device's disk space so that I can load that data back up and use it later. So I've now like forced closed the application, and if I open it up again, you'll see the same notes there. So we can create, edit, delete, save notes, all to persistent storage. So that's the app that we're going to.
And you have to write the code to take it from the app, from in-memory, and then persist it, right?
Yep.
Okay.
So we're going to look at how to do that and everything too.
Cool.
Todd, what's fascinating about this is you showed us the code that runs this, and it's actually very minimal because you're calling on pre-written libraries for most of this, and you could make it look beautiful with actually little effort.
Yeah. And that's, you're talking about people being married to IDEs and editors, and I kind of feel that way with Xcode. It's pretty convenient a lot of the time.
Yeah, and you've probably developed some pretty good muscle memory, not just for keystrokes, but you know where all the pieces are, so why would you ever develop in something else?
Right.
Yeah.
Right.
Yeah. Oh, let me ask you one thing. So this is going to store on the local device. That's where the memory persistence is going to occur. Right. If I wanted to create an app that would, say, use a third-party API like Dropbox, and I want to be able to store up in the cloud on a third-party service, are there libraries for that, or would I already be able to do that with the libraries you've just brought in?
Well, you could use iCloud. That's already built into iOS. So you could save the type of data that we're saving right here is pretty easy to save to iCloud. It only takes a few lines of code. And I actually have a course about that. So you can do that. Some things like Dropbox do have existing APIs. Actually, most popular services have APIs already that are pretty easy to use.
Right. And I got to ask this. What about reaching across applications in iOS? Because iOS does have a sandbox, and there have been some issues that were recently discovered, but on a whole, it works really, really well. If this was a different kind of app, let's say instead of a note-taking app, we were creating some sort of graphics app, and I wanted to be able to pull graphics from other applications on the phone, or maybe even from the gallery on the phone, how much more complicated does that become?
Are you talking about like if I made an app, like a graphics app, and I made a note app, and they need to talk to each other?
Right.
Is that what you're talking about?
Exactly.
Okay. Because we don't have access to other apps on the phone.
Right.
Like other third-party apps. We can get the photos and everything, but we can't have access to all the third-party data and stuff. It's not that complicated. You can save your using iCloud. There's some setting where you can create this kind of ID that you link to different applications that you have, and those can share data with each other.
Got it. Okay, so if you want to share data, probably the best way to do is to take it off the device, because it's supposed to be pretty well partitioned on the device. Yes.
Right.
Okay.
And Todd, you could use there's ability to use AirDrop too, I think, where you can send data between applications, I think, in iOS, isn't that?
Oh yeah, you could do that.
Okay. All right, I took us off the rails long enough. Take us back into the app.
Okay, back into the app. Let's actually I'm going to go back to Xcode, and I am going to build the app. This is the welcome screen, what you're going to see when you launch Xcode. In Xcode, you go to File, New Project if you don't see it on the welcome screen, or you can just click Create a New Project. So here I am, and I should be able to just share Xcode now. So I'm going to try to do that. Hey, still doesn't want to do it. Okay, I'll come back in one more second after I finish this part.
Okay.
Under iOS application, we're going to choose Master Detail Application. So, and I'll show you in just a second what you get as a starting point with this app.
Okay.
So I'm hitting next, and the product name, I'm just going to call this, I'll call this Notes app. And then I'm going to choose Objective-C for the language. By the way, I've been using Swift a lot. I feel like it's a lot more stable. Tons of changes has happened lately. But once Xcode 7 releases, then I would say go for using Swift. So
they're close. They're close, but you would still recommend people start with Objective-C.
For now, yeah.
Okay.
For now, for the next couple of months. Once they launch Xcode 7, I'd start using Swift. Okay, so for devices, I'm choosing iPhone only. I'll hit next, and I'm going to save this on my desktop. Hit create, and here I am in Xcode. And I'm guessing GoToMeeting will let me share Xcode now. Yes, yes. Is that working?
Yep.
Got Xcode. Okay, good. All right. I want to show the code that's in here real quick, and then I'm going to show the starting app that we have so that you can kind of see that, like, where we're starting from. Actually, I'll show the app first. That's probably better. Let me get the... I'm going to hit the run button to run. This is the template app. This is not the finished app. This is what you get when you just make a file directly from the template. Okay, and I'll tab over to this. You see the simulator now?
Yes, we do.
Okay, so it looks pretty much the same, but when I hit the plus button, I don't see a note, and I'm not taken to the detail view. I see a timestamp. And so I click a bunch of these, and I see the timestamp. And if I click on any of the timestamps, then I see the timestamp in a detail view.
Right. And this was that first part of the code where this is how you organize the data, but you haven't attached anything to that timestamp yet.
Right, yeah. Right. And instead of holding it in the array that the template provides, we're going to make our own custom array that's going to hold note objects instead of just an array of strings.
All right.
So I'm going to delete the rest of these. And this actually doesn't save to persistent storage by default. We have to write that code manually.
Oh, so okay. So in its default configuration, when you shut down the app, that data would be lost.
Right.
Okay.
Right. But it's pretty easy to do, to save to persistent storage in iOS. And there's lots of ways to do it. You can save to a file. You can save to a really simple format, and we'll use the simple format here. Okay, so I'm going to start. Oh, well, let's look at the code. Wait a minute. I think I gave you guys a good enough tour of the code.
Yeah, we've seen it.
You've seen enough. It's not going to. It pretty much looks like what you saw earlier with the few lines that I added.
And we're going to make it available to users off the show notes, so they don't have to copy it off the screen here.
Okay, good. I actually do have the finished project. I've saved that, so I can provide a link to that if your users want to download it.
That would be perfect. Yes, I'd love that.
So yeah, I'll provide that after the show. Okay, so I'm going to create a new class. I'll go to File, New, File. And under iOS source, I'm going to choose Cocoa
okay, we're not
class.
getting Xcode again.
What? Oh, okay. Oh, I forgot to change it. So what I'm doing is going to File, New File. You can also push Command N. So do you see this choose a template for your new file thing?
We do not.
Okay. Okay, that's not a big deal. So on the left side of that window, you're going to see iOS, and then under iOS, you'll see Source. And click on Source, and on the right side of this menu, you're going to see the first option, which is Cocoa Touch Class. So hit that and click Next, and we'll name this class Note with a capital N, and it's going to be a subclass of NS Object, and that's going to be all one word, NSO, or all capitalized.
Is that the default that you want to do all the time? Just always subclass of NS object?
Not all the time. This is for this class, yes, but sometimes you're going to subclass a view or a table view or table view cell or whatever. So we have an NS object here. Language is Objective-C. Then hit Next. Then you choose where to save this. You shouldn't have to change any of this stuff. Just hit Create. And then you should be in your Note class.
There we go.
Okay.
So that process probably sounded more complicated than it was. It's pretty easy. So in the Note class, we're going to have to define all of the properties and methods that we're going to need to manipulate our data. So we'll start by writing an import statement. And this is because the default import statement doesn't cover all of the iOS user interface access that we're going to be referencing in our code. So I'm going to import the code to use those assets, and that code is inside of less than and greater than signs, uikit/uikit.h. And underneath the interface declaration, I'm going to declare two properties using the @property callout. And this is going to be of the type NSString. We talked about that in the earlier tutorial. Mm-hmm. And the first one will be called Note, and the second one will be called Date.
And Todd, why did you choose a string for the date?
That is a good question. You don't have to. I could save it as a date object and not as a string. For what we're doing here, it doesn't really matter either way.
Got it. Okay.
Because once I grab the time code and convert it to a string, it actually converts back to a date really easily without really having to mess around with it too much.
Got it. Okay.
Okay. And the methods that I'm going to declare here are all going to be class methods. So we start with a plus sign. And the first one is going to be a UI table view. And a UI table view is that big list that we saw on the screen. It's on the main menu, and the thing that's added to when you hit the plus button. So this is just going to be a getter for that. So we'll call it getTable. And then the next one is going to return void, and this is going to be the setter for that. So setTable, and then it'll accept a type of UI table view. And I'm just going to call that T. And moving on, I'm going to create a method to save the notes and one to load the notes. And then I'll need to access the, since our data is stored in an array, I'm going to have a property that just keeps track of what index of the array that we're working in. And that's going to be called current node index. And so I'm going to write some getters and setters for that here. So here is the setter. And we'll call that property, or call the parameter index. And then the last one is going to be a getter for all of our notes. So this is going to return an NS mutable array. I think we talked about that in the last tutorial.
I think so, towards the end.
Okay, mutable is something that can be changed. So an array that we can modify objects inside of. So that's why we're using, instead of a standard NS array, we're using a mutable one, because we're going to be changing the data that's inside of the array whenever we manipulate or create a new note. So we'll call this method getAllNotes. And that is all the code for this file. And so we'll go over to node.m, and we're going to need to implement all of those methods that we declared in the header file. And I'm going to start above the implementation line, and I'm going to add a define line of code. This is going to declare a constant value. And this is going to be the key that we're going to use to save data to our persistent storage and to load data from persistent storage.
Okay.
Cool.
So,
like a key value pairing.
Yeah, exactly. That's the simplest way that iOS handles persistent storage is by key value pairs. And we literally just say, save data for the key KL nodes.
And I take it that's just the same key that you're going to use when you want to pull that data from persistent.
Exactly.
Okay.
Exactly. So, and this string right here, all the nodes, is irrelevant. You can type whatever you want in there, and it'll work just fine. So I'm going to declare the current node index. This is going to be a static integer. I'm going to set it equal to -1, just so we know if we try to check it, that we know that it's not initialized if it's -1. And then on the next line, I'm going to create an NS mutable array. And this is going to be all nodes. And I'm going to initialize it to nil as well. So I'll make sure to add the semicolons at the end of these lines.
It would let us know.
Yeah, exactly. It was bothering me. So I have my notes array. This is our main object for storing data. So when it's set to nil, which is the same thing as null in other languages, it has no value. And so if it's nil, I know that I haven't yet loaded the data. So on the next line, I'm going to declare that.
Todd, is that not the default value for a variable is null or nil, or
Yeah,
do you actually have to set it?
It is. It's the default value. I'm in the habit of doing this. One time I had a problem where I actually needed to set it to nil first for some reason. And that haunts me to this day. So I'm in the habit of initializing stuff to nil sometimes.
Got it.
But yeah, it would probably work just fine without that.
Yeah, but why not? I mean, this way you can
yeah.
see on the screen, yes, it will be set to default value. There you go.
Right. Yeah. So then I'm going to create our table view. I'll just call this table here. And then inside of the implementation file, we're going to basically just, write the skeletons of all of these methods. So let's do that. So the first thing we're going to have to do is for these properties on line 14, we're declaring them here so that we can access these property values using dot syntax. And if we just declared them as regular properties without using the @property callout, we could still access them, but the dot syntax just makes it a little more convenient. And so I prefer doing that way. And when you write property, do the property declaration, you're supposed to write getter and setter methods for those properties. But iOS will, I think we talked about this too. We probably talked about synthesize before. But the synthesize makes that code be written behind the scenes, basically. So I'm going to synthesize both note and date. So I don't have to actually write getter and setter methods now. And then I'm just going to implement all of those class methods that I wrote out. So I have the one that returns UI table view, and this is called get table. And in there, I'm just going to return the table. Oh, and the setter for that for the table. Just filling that out, and I'll just set table equal to T. It's really simple, straightforward stuff. We have the one that returns all the notes. So we'll return our notes array. And then...
So in your implementation of all these, you're basically just setting everything to default.
Pretty much, yeah. Right, that's what I'm doing right now. Since these are all class properties, the way that this is going to be set up is that we can access the table through these class methods. But yeah, for the most part, this is all just the default obvious stuff.
And on the flip side, you're going to try to bind the UI to these properties, right?
Some of them, yes.
Okay.
Yes. Like the table view can't be set until we set it in another class.
Got it.
Yeah,
okay.
we'll look at that. So I'm returning the node index, just the same boring stuff. Setter method for that, set current node index. Okay. And then now the interesting stuff. So I'm just going to write the skeleton for save notes and load notes.
Okay, here we go.
Yeah, now we're actually going to start writing some code. And we're also going to need an initializer. So I'm going to write the Objective-C init method. And Xcode has a handy shortcut for doing that. You just type out init, and then you'll see this Objective-C init method highlighted. And you press return, and Xcode writes this nifty block of code. So in here, I'm just going to initialize. So if we create a new note, I'm going to give it some default properties. Again, just like I've been doing so far. Everything's initialized to the default. So note is an empty string, and date is going to grab the current timestamp, which we can grab by calling nsDate date, and we turn it into a string by using its description property.
Got it.
So yeah, if you wanted to save it as a date, you could just delete that, and boom, there's your date object.
Which would give you, I guess, more searchability on the individual parts of the date if you wanted to search by month or.
Yeah, exactly. And we could also construct a date object with a string, and this will convert right back into a date object just fine later.
Right.
So yeah.
You could even sort the stack by if it was a data object too, right?
Yeah.
Yeah.
Okay. So this. Okay, then we want to one more thing to initialize that's boring, and then we'll get into the interesting.
And then we get to the fun stuff. Okay.
Yeah. Yep. Got to do all the prep work first. So what we want to do is make sure that if all notes is nil inside of load notes, that we initialize it. And so I'm going to initialize it using the NS mutable array. The class method array with array, and then I'm going to create an array shorthand.
Okay.
Does that make sense? This is the create an NS array, but I have to create an NS mutable array, so I need this wrapper for it.
Right. The very first time it runs, it's going to find that it's nil, and it'll do that, and then we're good to go. It's ready for us.
Good. Okay. So then I want to, when the app launches, I want to run load notes, and then I want to set the table. And so we're going to do that real quick. So I'll go over to masterviewcontroller.m, and you write this initialization code in the method viewDidLoad. So in my code, that's on line 23. If you don't see it, you can do a search for it, or you can do this handy method by clicking over here where it says M up in this jump bar right here. I don't know if you'll be able to see this when it opens up on my screen. But if you click that, you'll see a list of the methods that are inside of this class. And so then you can find viewDidLoad by there. And if you hold Command when you click that, you'll see the methods sorted in alphabetical order. So, pretty cool trick.
That's neat. Yeah, that's neat.
All right. So under this comment in viewDidLoad, I'm going to initialize all the notes by calling, I can't reference the note class yet. I need to first import it. So don't want to forget to do that. So I'm going up to where all the other import statements are at the top of masterviewcontroller.m. And then I'm going to import in quotes note.h. And I'm going to do the same thing in detailviewcontroller.m before I forget. Okay. Oh, there we go. So back to masterviewcontroller.m, and we're going to need to load the notes and set the table. So we load all the notes, we're calling note, load notes, and then we set the table by using that class method note set table. And the table can be accessed through this class. The master view controller, you can think of that as the code that controls the main user interface when you launch the app, the one that has the plus button and the edit button and the list of notes. So we can access the table by calling self.tableview. And so at this point, if we were to run the application, nothing would appear to be different. Because all we're doing is just initializing our note class and connecting that table view to the note class.
Right. We still have nothing to put anything in the table, pull anything out of the table, or write or read from persistent storage.
Right. Good. Good. Okay. So it's all making. I'm glad that you guys are keep saying stuff so that I make sure that what I'm saying is making sense.
Making sense.
Yeah. You know, it's nice. Okay. So the next step, and this is where it starts getting interesting. Okay. We want to be able to save our array of notes to persistent storage. And you can do this in a number of ways. Our array called all notes, it doesn't have anything in it. And in Objective-C, arrays aren't data typed to a specific type of information that can be stored in the array. So we can't say this array only contains notes, or this array only contains monkeys, or whatever code objects you have. There's only the generic type of NS mutable array and NS array. So an array just contains objects.
Is that just because they're pointers to objects and it's pointers to anything?
Right.
Got it.
And
okay.
in Swift, though, you can say it's an array of note objects. So that's kind of nice there. Here's the thing about this, where we get problems. Okay, our all notes array is going to contain an array of note objects with our custom properties that we have right here.
Right. So the note plus the date in a string.
Right. Even though this is simple data, as it is right now, this object, a note object, cannot be saved to persistent storage, and an array of notes cannot be saved to persistent storage. So we need to make our note class compatible with the type of data that you can save in persistent storage. So by default, unless we alter our note class, persistent storage only stores strings, numbers, booleans, dictionaries, and the values in the dictionaries can only be strings and numbers and booleans, and arrays, and the values in the arrays have to be strings, numbers, and booleans, if you see where I'm going with this.
Right.
It all has to be primitive data, and we have our custom data type, which is called note. But so one method I've explored in saving the data is just converting our note class objects into dictionaries, right? We have a property called note and a property called date, and just key value pairs, simple stuff like that. But what I'd like to show here is kind of the more advanced method, which is making the note class compatible with saving data to persistent storage. So we can just simply save our notes to persistent storage.
When you say that, you're going to try to save the object as a text.
Well, it's going to save as a key value pair, and when we save it as a key value pair, we convert it into this this Objective-C type called NS data, which if you were to print that out, it just looks like a bunch of binary gunk.
Right.
But in order to convert it to NS data, we need to modify the class a little bit. So
that's almost like it's the iOS or the Objective-C version of, in other languages, like binary serialization or something like that, where you're got it. Okay.
Yes, exactly. In Objective-C, it's called NS coding is the class that we're going to use. So if we go back to our note header file, we're going to implement the NS coding protocol. So right after NS object on line 12, I'm going to put some brackets, and those are the greater than, less than brackets. And in there, I'm going to write NS coding. And so if you look in here, you can see some information about what NS coding does. And if you click more, you can kind of read more about that. I don't even know if you can see this pop-up window, but there is more information about that if you'd like to read on it.
Todd, but before we go on, let's go ahead and take just a moment to thank the second sponsor of Coding 101. We'll get right back into this. We're going to find out how we're going to make all of this data fit into a simple data type so that we can actually put it into persistent storage. But first, let's go ahead and give a word to Braintree. Now, if you are watching these episodes, it's probably because you're interested in developing apps for iOS. And who wouldn't? I mean, Todd can tell you that the #1 profitable environment for apps today is in iOS. I mean, that's where the money's going to be. That's probably where you're going to want to go program. But if you are going to program in iOS, you're also going to need a way to have financial transactions in your app. And that's where Braintree comes into play. Rather than setting up your own relationships with financial companies and standing up your own servers and making sure your back-end code doesn't reveal any personally identifying information from your customers, you can count on Braintree to do that for you with their V.0 SDK, all in 10 simple lines of code. Now, it's simple, secure payments, code that you can literally integrate in minutes. Now, what I really like is the fact that if you're having trouble with your integration, they'll have one of the representatives babysit you. They'll do it for you. They'll walk you through step by step to make sure that it's going to work. And you can even try out their sandbox to make sure that your app looks right, that it responds correctly, and that the financial transactions are as protected as Braintree says they are. Now, the V.0 SDK makes it easy for you to accept multiple mobile payment types, including PayPal, Apple Pay, Bitcoin, Venmo, cards, and more. And that Braintree code supports Android, iOS, and JavaScript clients, as well as their SDK being in 7 different languages: .NET, Node.js, Java, Perl, PHP, Python, and Ruby. It's elegant code with clear documentation, and as I said before, it's just 10 lines of in-app code. It really doesn't get a whole lot simpler than that. Now, here's what we want you to do. We want you to do right by your app. Braintree gives you an easy way to accept multiple payment types with that one integration. Start accepting those payments today with the Braintree V.0 SDK. One small snippet of code and you're up and running in less than 10 minutes. To learn more and for your first $50,000 in transactions fee-free, go to braintreepayments.com/coding. That's braintreepayments.com/coding. And we thank Braintree for their support of Coding 101. All right, Todd, so now we've got this bit of an array that we want to be able to push to persistent storage. But as you say, we can't do that. We need a simpler data type, and we're going to do that how?
What we're going to do is take our note class and say that our note class is compatible with serialization. And the way that we do that is we implement the NS coding protocol. And what that means is we're going to support 2 extra methods in our code that are just going to make our note class compatible. So let's look at how that works. I am back in note.m, and I'm going to implement those 2 methods now. The first method is called init with coder. So I'm going to just select that in the code hinting window and press return on my keyboard. And here's the method right here. Nice and easy. And in the call to super, I'm getting an error because note is actually a subclass of NSObject, which doesn't have anything to do with NS coding. And so when it tries to call super init with coder, it's throwing an error there. So if I just delete with coder, then my error goes away.
Right.
And I'm going to write the code, like what this thing does, in just a second. I just want to implement the other method because I think it'll make more sense once I add the other method first. So the other method is to encode with the coder. So that's going to be encode with coder. So I'll start typing that out. And we have a call to the super method here. I'm just going to delete that because we don't need that. So we need these 2 methods. So encode is what makes your note turn into something you can save in persistent storage. And then init is when you're pulling it out of persistent storage, note objects will be made, and it uses this method to initialize those note objects. Does that make sense?
Yes, it does.
All right, perfect. Okay, so we'll start in encode with coder. And I'm going to write some brackets, and I'll call coder, which is the object that's going to encode my data, and it will be encode object for key. That's the name of the method. So when it pops up in code hinting, press return on my keyboard, and the object I want to encode is note, and the key is just going to be the string value of my note, or not the string value of my note property, the string name of my property, which is just the string note. Now, it doesn't really matter what I call this string. I'm just calling it the same name as the property because it's easier to remember. And if I wanted to, I could, of course, make constants to work with this instead, but I'm fine just doing it like this. So I encode that property, and then I copy and paste that line of code and do the same thing for the date. Encode the date for the key date. And then in init with coder, we do the opposite. We set the property values based on the encoded values. So note equals coder, decode object for key, and the note key is just note. Yeah.
No, Todd, should you be testing or verifying whether they exist in the dictionary before you actually set them like this?
Yeah, I mean, you could of course do that. But the only way that this init method is going to be called is when they're pulled out of that dictionary.
Got it. Okay.
So, yeah, I mean, yeah. You could call this sloppy code if you want, but yeah, of course, yeah.
Get her done.
You could
code.
always,
all right.
Yeah, get her done code. Yes. Oops, I didn't mean to build. My finger slipped. All right, so I'm going to do the same thing for the date here. So we're decoding the date, and now we're going to write the code that it's called archiving to convert these objects to the raw data that can be then saved to persistent storage. So I'm going to go up to, let's go to save notes first. So we haven't called this method yet because we don't have any data to save. I'm just building out this note class so that when we are ready to save the data, we just run the method and boom, the data saves to persistent storage. So first step is to convert our array of notes to an NS data object so we can then save that data to persistent storage. So I'll call NS data. I'll call this data. Yep, like that. And then the method that we're going to use to convert our array of notes to data is NS keyed archiver, archive data with root object. So then we pass in our array of notes, which is all notes. And I'm actually going to hide this utilities area, the right area of the screen, so that that fits on one line. And this converts our array of notes into a data object, which we can then save to persistent storage. Now, without implementing the NS coding protocol, this line of code would cause problems because the note class doesn't support being transformed into this type of data. So on the next line, we're actually going to save the data to our storage. And I love in iOS how easy this is. I'm going to write double brackets and in an inner brackets, NS user defaults, standard user defaults, and then in the outer brackets, set object. Object is going to be data, and the key is going to be our data saving key, which is K all notes. Remember, we defined that above, right here. And this one line of code is all you need to save data to persistent storage. It's just set object for key. And then when you load the data, the method is object for key, and it spits out the data right from the persistent storage. So
that's fantastic. So right here, yeah. this little piece is what's going to translate it into something that can be saved. And then, of course, we're going to have to bring it back at some point when we want to load notes from persistent memory. So
right.
Yeah. Unfortunately, Todd, we're going to have to save that for a future episode because we're running towards the end. I don't want to squeeze in too much at the end here because this is actually getting very important. When you have to start modifying memory on the device, I think we need to be fresh. To give people just a sneak preview of what they're going to get the next time, of course, they're going to get the remainder of saving persistent data. They're going to get pulling from persistent data and turning it back into our usable array. And then they're going to get the rest of the functionality of our note-taking app. If you were going to give a homework assignment to the good folks at home watching along, what would you want them to do? Because, of course, we haven't given them everything they needed, but you've given them a lot.
I would say we talked before about creating objects, right? Creating user interface objects and connecting them to our code. Try creating a user interface object, maybe a text area where you type some text or a button or something else, and saving some data to persistent storage using that.
And of course,
using this set object for key.
We're going to make your code and even your program available. We'll make sure that ends up in our show notes so that people can pull that down and just start toying around with it. The simulator is a great place for you to try and error. Now, if they wanted to find out more about your work, because of course we got you from lynda.com, so they can absolutely check out your courses in iOS on Lynda, but where else can they go to ask Todd?
Find me on Twitter, Ask Todd.
Twitter.com/AskTodd. Todd, it's been a pleasure. We will see you again next week. Same bat time, same bat channel. And, sir, it is always fun to talk to you.
Thank you.
Also, we want to thank our co-host, Mr. Lou Maresca. Lou, I wouldn't want to do Coding 101 without you. You make everything so much more fun. Could you please tell the folks where they can find you and your work?
Thank you. Yeah, so you can always find me, LouMM on Twitter. And, of course, all my work I do at Microsoft is at crm.dynamics.com.
And folks, don't forget that you can always find us at our Twit page, twit.tv/code. Just go to Twit TV Code and you'll find all of our episodes along with show notes. We've also got a menu there, so if you want to get our episodes automatically downloaded into your device of choice in your format of choice, you can do that with just a click or two. Also, if you're going to watch us, why not watch us live when we are live? We usually tape on Mondays at 2:30 p.m. Pacific time, live.twit.tv. And if you are watching live, jump into the chat room at irc.twit.tv to be part of the experiment that is the Twit TV Army. Finally, I want to thank everyone here who makes this show possible. Of course, to Lisa and to Leo for letting us do Coding 101. And to my super TD Eskimo Zach. Zach, could you tell the folks where they can find you on the Twit TV network?
Yeah, Padre, you can find me on Twitter, where I want to give credit to Freddy the raccoon that you see right there. Right now, I'm about to pass Freddy in followers. I'm one behind, and he got me started with my big following in the first place. So thank you so much, Freddy.
You just never know what's going to happen whenever we throw to that camera. Until next time, I'm Father Robert Ballister. That's Lou Maresca. This is Coding 101. End of line.